Hello YouTube, welcome to another JavaScript tutorial. This tutorial deals with advanced password strength. Okay, how I got this idea? Well, this idea was based on the old news, and not too old, maybe about 2 weeks ago, when Yahoo Mail, either Yahoo or Yahoo Mail, got hacked, and the hackers basically exposed 400,000 passwords, give or take. So that sort of gave me an idea, like, okay, what can I do to help people build good passwords? So I came up with this tutorial. Alright, so obviously, if you had a password, if your password was, let's say, password, as you can see, that's a weak password. It takes less than a year to crack. I mean, that's just horrible. I don't know why anybody will have that. In fact, even if you typed it uppercase letter, that's horrible. Alright, now how do we build good passwords? So I'm just gonna pick some random characters. So let's say YouTube 23. Look at that, YouTube 23. This is just some random password I just made up, but look at how strong that is. It takes about 428 years to crack. Again, all these numbers are theoretical. Somebody or a machine can be lucky to guess it on the first try or the 20th try, but this is theoretical. So obviously, the larger the number you want it to get, the more time it takes to crack your password. So why is this strong? Well, obviously, we have a big pool of characters that we use to build our passwords, which in this case, it's all lowercase letters and digits. Okay, so, and also the number of characters that we have. So how many characters do we have? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 characters. 9 characters, a mixture of letters and numbers, gives you a strong password. Now, if you really wanted to make it strong, well, just add a space. We're considering a space as a character. Look at that. They jumped from 428 years to 31,000 years. Yeah, I don't know about you, but I'm not going to be there. I'll probably be dead, and I don't want to use Justin Timberlake's song. Let's just say I'll be dead. Oh well. Alright, so hope this makes sense. You know, you can mix it up with different characters. My suggestion is always to use a combination of letters, characters, and numbers. So let's say my name is Fluffy. See that? When you write your password like this with a combination, matter of fact, let's even make it fancier. With a combination of uppercase, lowercase letters, characters, and numbers, it makes your password ridiculously strong. Look at that. That's a long time to crack. Alright. Let me give you guys let's look at the theory behind this, how I came up with this. This involves some math, so it's not too bad. So I'm just going to take it slowly and explain. Okay, so for the first one here, we have the number of characters. So this is basically a set of characters. So each X represents a character. However many of them gives us R, which is the number of characters that we have. Again, we said we're including spaces. Okay? So if we had a 5-character password, then R will be 5. If we had 10, R would be 10, so on and so forth. We also need the number of seconds in a year. I found out that the number of seconds is 31,557,600 seconds in a year. Alright, so we're dealing with characters. So that means, if anybody's familiar, we're dealing with permutations. But this will be slightly different because we have some objections, or some exceptions rather. So with permutation, we're allowing repetitions, but we want to make sure we don't have any double count. Okay, so before I show you guys the example, let me show you guys the formula. So the formula says for each character, okay, let's say we had lowercase letters. How many letters are in the alphabet? There are 26. So for each character X, there are 26 choices that I have to put here. 26 choices that I have to put here. Again, we're allowing repetition, so on and so forth. So that's why we have the product here. Okay, this is a symbol for product. So this tells us that for each X that we have so many of them, whatever our pool of characters are, which is represented by N. But we said we don't want double count, because if we have, let's say we had a 3-character password where it's all the same. Let's say our pool of characters are just digits. So let's say it was 333. Okay, so you have repetition. So theoretically, we can rearrange those 3 in different slots. How many times? 6 of them. At the end, you still get 333. So we only need 1 of them, so we have to throw the other 5 away. Hopes that makes sense. This is for the repetition. Okay, and that's what's covered over here. Okay, so the R exclamation mark, that's for the factorial sign, says however many ways we can rearrange them. So if it's a 3-character, we have 6 ways. If it's a 4-character password, we have 24 ways. 5-character, we have excuse me, let's see, what's my math? What is it? 24, that's 48, 96, no, 48, 120, sorry, jeez, huh. Sorry. Okay, so we have 120 ways of rearranging them, but we only need 1 of them, so we got to take away 1 of them because it's already counted over here, so we don't need it to count it twice. Alright, so when we expand everything, we see that the formula comes out to be n raised to the r, because that's n times n times n times n, however many characters that we have, which is basically an exponential, minus n times r factorial plus n. Okay, that's what the math works out to be. So that's our modified permutation. All right, let's see an example explaining the repetition I was talking about. So let's say X is our pool of characters. Okay, 0 through 9. So obviously we have 10 digits. So the count of X equals 10. This 2 bars in math simply means however many things we have inside. Okay, just like in computer science array, the count function or the length, it counts however many things we have in here. So as you guys can see, we have 10 digits. So that will be our pool of characters that we're going to use to make our password. So let's say we want to make a 3-character password. So R will be 3. Okay, remember we said it here. Okay, so suppose our password was 111. Simplest case. Okay, as I told you guys, there are 6 ways we can rearrange them. So let's say this one is here, this one is here, this one is here. So we rearrange them, we can rearrange them 6 ways. Well, at the end of the day, like I said, it's still the same numbers. So we have to throw these away. So if we plug in our 10 digits pool, we only need 3 characters. We're gonna have 950 ways excuse me, we can form that password with just our pool of numbers. Okay. All right, so how did we compute how to crack it? Well, number of years. So we know that our answer that we're trying to get is either going to be 0 or more, which is this is represented by this. So it says that the number of characters, big C, has to be a whole number. It has to be a natural number including 0, which is simply by saying all the integers except take away all the negative numbers. Okay, this is just a fancy way. So this is number of C is an element of naturals union 0. Alright, so if we plug that in here, so we see we have however many ways we get, and then this 1 million represents theoretical attempts per second. So for example, if you had a distributed computer system, okay, that tries 1 million passwords or 1 million attempts per second, that's what this is represented, then that means in a year, which is 3155 whatever, gives us this many attempts in a whole year. So however many ways, divide that by however many attempts, take the floor, because this would give us sometimes decimals. So but we want whole numbers because that's what we're restricting it to be. So we take the floor, okay, to be not considerate, but conservative. So that gives us a number. I hope the math was not too much. I am so sorry. Forgive me. Okay, I will include this with the password. With the files for you guys to play with. All right, now let's look at the code itself. Here's the HTML, short, sweet, straight to the point, nothing fancy. CSS, same thing, nothing fancy. Alright, let's go to the JavaScript, which is the main one. Alright, so let's explain this real quick. So when the user loads up, we focus on the password box. Okay, so we want to add an event listener. So in other words, once the users start typing, okay, which is the key up function, once you start typing, call this function main. What is main though? You go to the function main calls a function called display strength. You pass it the IDs of the password box, the password strength, the status, and the number of years it takes to crack it. Okay, again, this is just to mimic jQuery. Okay, so this function right here, display strength, okay, is what paints. So in other words, it's what paints this. So if I start typing, this is display strength. That's what it's doing. Okay, this is the whole point for display strength. So we go through display strength. This is where we match up our pool of characters. Again, this has to do with regular expressions in JavaScript. So for the weak points, we're saying if our password is just all lowercase letters and uppercase letters, that will be a weak one. A good password means lowercase letters, uppercase, and digits, and so on and so forth. The next one is lowercase, uppercase, digits, and space. Remember, I have to escape space because the interpreter will not parse it properly. Okay, and then to make it really strong, uppercase, lowercase, uppercase, digits, space. Basically, these are all the characters above the digits on your keyboard. Make sure you escape them. You have to escape them because to JavaScript they mean something. So if you want them to be a literal, just escape them. And then count simply means the number of stuff in each pool. So obviously 52 represents the number of lowercase characters, which is 26, uppercase, which is 26. Add those together, it gives you 52. Here we have 52 plus 10 digits gives us 62. This one gives us 62 plus the space gives us 63, and then this one gives us 74. And then here you can adjust the number, the colors: red, gold, lime, dark green. Value: weak, good, strong, very strong. Okay, so once the user start typing, the function goes through each character to find out which group of characters it's matching. If it sees that it's all that, then it sends this number. Okay, so it's gonna grab that number from count. It's gonna send it to compute strength. Compute strength is down here. Compute strength is the function that we had written over here. This function right here, the permutation. That's what compute strength is doing. Okay, and then we gotta have a function to calculate factorial. Okay, which is this function right here. This calculates factorial for us. It returns the number, and then once it does that, then this function returns how many years it takes to crack. Okay, so once it gets that back, it registers it with the years, and then it checks it depending on however many years it takes to crack. So whichever one it matches, it draws and colors the appropriate color for the strength. Okay, so if it's more than 1,000 years, obviously it's very strong. But if it's between 100 but less than 1,000, it's strong. But if it's more than 10 years but less than 100, it's good. Anything less than that, it's weak. Okay, so hope that makes sense. Okay, I'll package this as a zip file for you guys to download and play with. If you have any questions, please do not hesitate to send me a message. Okay, thanks a lot, and good luck having a very strong passwords. Look at that. Thank you so much. Even takes a long time. Amazing.